Hi learners. In this video I want to talk about the remainder theorem, also known as the polynomial remainder theorem or polynomial long division. And what it involves is this idea of you have some crazy polynomial and you want to figure out if something is a root of it. Again, the big idea here is if you've got a series of things multiplied together and they equal 0, either one of these equals 0 or all of them equals 0, and that's the only way you could possibly have a solution, right, if it equals 0. So in this idea, what we're saying, hey, is 1 a root of this big polynomial, which means is x minus 1, because if positive 1 was x, you'd get 0. If I multiply that by some other polynomial, would I end up getting this, getting the entire polynomial? So what we do is division, and it's very much just like long division if you're going to take a big number. If you took a number like 42,750 and you divided it by 25, right, you would go through the process. You'd say, okay, 42, let's see, 25 goes in there once, and then you'd subtract. You'd say, okay, that's 17, I bring down a 7, 3, no. You know, basically that's the idea. If I multiplied that by 7, I'd get 175, right? That's long division. Well, you can do the same thing with polynomials. Let's go through it. Step number 1. Is 1 a root, which means is x minus 1 a factor? If this said is negative 2 a root, you would have x plus 2 as a factor. Take your polynomial, write it out. 4x squared minus 5x minus 2. Put your division box, and then put your root here, x minus 1. So what we're trying to do here again is this number times some other polynomial that we're going to fill in over here equal to this. All right, step 1. What number times x minus 1 will give you 3x cubed? Okay, well that number is 3x squared. Now watch, 3x squared times x is 3x cubed. Cha-ching! But then I also have, I'm doing distribution. I'm saying this number then times negative 1. So that would be 3x squared times negative 1 would be negative 3x squared. When you do long division, whether it's polynomials or just numbers, we always subtract this line from this line. So 3x cubed minus 3x cubed is 0. 4x squared minus a negative 3x squared is a positive 7x squared. Just like you do with anything else in long division, bring your values down, minus 5x. Next step, what number times x minus 1 will give you 7x squared? Oh, let's see, I already have the x. I need another factor of x, and I need a 7. Positive 7x. 7x times x is 7x squared. 7x times negative 1 is negative 7x. Subtract 0, negative 5 minus negative 7 is a positive 2x. Bring down the negative 2. Last one, it looks like. What number times x equals 2x? Well, that's just 2, positive 2. 2 times x, 2x. 2 times negative 1 is negative 2. Wait a minute. 0. There's no remainder. What that means is if I take x minus 1, multiply it by that whole gorgeous thing, plus 2, I get this polynomial. And in fact, what that means is, yeah, if I plug 1 into this polynomial, I can get it to equal 0, right? 1 cubed is 1 times 3 is 3. 1 squared is 1 times 4 is 4, plus 4. 1 times negative 5 is negative 5, minus 2. 7, negative 7, that equals 0. 1 is a root, right? X minus 1 is a factor. That's a way to check. I'm going to take this existing problem. If you want to call it good here, call it good here. What if, for just one moment, you went through this whole procedure, but the last step on this problem right here, this number was a -3 instead of a -2. So that means down here, this would be a -3 instead of a -2. And -3 minus 2 would be a -1. Hence, the remainder part of the theorem. What that actually means is, you still have this polynomial being multiplied by this one, but there's one more part to it. Whatever this remainder is still being divided by the brain fart, forgetting the term for the thing you're dividing by. But anyways, you'd put it right here like this. 1, because it's minus, -1 over x minus 1. And a long story short, if you multiplied this by this, you would get that polynomial. But that also tells you that this 1 is not a root, right? It's not. If you plugged 1 into this original equation, you would add a -1 left over, and that wouldn't really help you out. So this process of polynomial division, the remainder theorem, is to help you determine whether things are roots. This is the long way to do it. We're going to teach you the shortcuts, the easier ways as we go forward, but you have to understand where this is coming from in the first place. I hope this helps. If you like it, please like the video. Please share it with your friends, your family, your dog. Let them know that you've learned something new today.